E-Maths class, Fatima Convent High School, myself, Dipali. Chapter 8, Quadrilaterals, Class 9. In this third session, we are going to understand two more properties related to quadrilaterals. We understood that a diagonal of a parallelogram divides this quadrilateral into two congruent triangles. In a parallelogram, opposite sides are equal, and if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Now let us understand the fourth property. That is, in a parallelogram, opposite angles are equal. Now opposite angles, what are the opposite angles? Then when you draw a quadrilateral like this way, that is a parallelogram, then this angle and this angle is said to be opposite angles. So A, B, C and D. Then angle A and angle C are opposite angles. Likewise, angle D and angle B is also opposite angles. So these two angles are equal. Now for this, let us perform an activity. You must have seen that in a parallelogram, each pair of opposite angles is equal, and conversely, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Can we conclude the same result for the pair of opposite angles? Draw a parallelogram and measure its angle. What do you observe? Each pair of opposite angle is equal. Repeat this with some more parallelograms. We arrive at yet another result as given below. In a parallelogram, opposite angles are equal. Now, is the converse of this result also true? Yes. Using the angle sum property of a quadrilateral and the result of parallel lines intersected by transversal, we can see that the converse also is true. So, if a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Let us prove that. Here is yet another property of parallelogram. But before that, we will prove this. If a quadrilateral, each pair of opposite angle is equal, then it is a parallelogram. So let us take a quadrilateral. Now this is quadrilateral A, B, C and D. It is given to us that in quadrilateral ABCD, angle A is equal to angle C and angle B is equal to angle D. Now we have to prove quadrilateral ABCD is a parallelogram. How shall we prove? For this we will take the help of the previous theorems. Now proof. What is the proof? Now if we draw any one transversal, say AC or BD, then we know that AC is a diagonal. Let AC be the diagonal of a quadrilateral. Now we know that in this quadrilateral, angle in quadrilateral ABCD is divided into two triangles, triangle ABC and triangle ADC. Now here angle B is equal to angle D, which is given to us. Angle A is equal to angle C. That also is given to us. Therefore, half of angle A is also equal to half of angle C, which is angle BAC is equal to angle BCA, and angle DAC is equal to angle DCA. So if these angles are equal, then we know all these four angles are equal to each other. Now we know that angle BAC is equal to angle DCA from 1 and 2. Now they are also alternate angles. If alternate angles are equal, therefore AB is parallel to CD. Now if opposite sides of a parallelogram of a quadrilateral are parallel, then quadrilateral ABCD is a parallelogram. We can say that from the given theorem that if the pair of opposite sides of a quadrilateral are equal, then it is a parallelogram and they are parallel to each other. Now here it is parallel, and also we know that according to AAS theorem, it is a congruency because AC is equal to AC. So in this triangle, two angles and one side, that is by AAS congruency, it is a congruent triangle. So triangle ABC is congruent to triangle ADC. Therefore, it is a parallelogram. Hence, it is proved. Now, let us see the next property. That is, if the diagonals of the quadrilateral, this property is related to the diagonals. Now, there is yet another property of parallelogram. Let us study the same. Draw the parallelogram ABCD and draw both its diagonals intersecting at point O. Measure the length of OA, OB, OC. You will observe that OA is equal to OC is equal to OB is equal to OD. And O is the midpoint of the diagonals. Repeat this activity for other parallelograms. What do you observe? Diagonals of a parallelogram bisect each other. Now, what would happen if the quadrilateral of the diagonal bisect each other? Will it be a parallelogram? Yes. So, if the converse also is true, that if the diagonals of the quadrilateral bisect each other, then it is a parallelogram. Bisect each other means divides each other into two equal parts. Means this part A, O and OB will be same. Let us prove that. Now here, OA is equal to OC and OB is equal to OD. Therefore, triangle O AOB and triangle COD are congruent. Why? By ASA congruency. These are vertically opposite angles. And therefore, angle ABO and angle CDO are equal. And therefore, it is AB is parallel to CD and and BC is parallel to AD. Therefore, ABCD is a parallelogram. So, we have already proved the four properties. The first property says, again a repetition, diagonals of a parallelogram divides it into two congruent parts. If each pair of opposite sides of quadrilateral is equal, then it is a parallelogram. In a parallelogram, opposite angles are equal. The diagonals of a parallelogram bisect each other, and if the diagonal of a quadrilateral bisect each other, then it is a parallelogram. On the basis of these properties, we are going to prove and solve various examples and exercise after that. Thank you for now.